Hi, we're here now to start part of Unit 3. Unit 3 deals with business statistics, data presentation. This is a fancy way of saying we're going to talk about some of the basic graphs, how to interpret and read them, as well as how to create them. So today we're going to be looking at Chapter 21 in your textbook, your e-text that is, the very first section. This is a part of Unit 3, so we are moving right along. All right, so what have we got here? This is where we're going to say, yep, data interpretation and presentation from Chapter 21, Section 1. There are three main types of statistics. Business statistics is the process of collecting, interpreting, and presenting numerical data about business situations. There are both descriptive statistics, that is, statistical procedures that deal with the collection, the classification, the summary, and the either tabular or graphical presentation of data. Tabular just means in tables, and graphical means we're talking about the basic parts of, or the basic types of graphs. And then the last part is some statistical inference. And we'll do a little bit of this, but statistical inferences is just the idea that we can arrive at conclusions, we can make predictions and forecasts, and even estimates based on the data that we're looking at. So mainly what we're going to be doing right now is descriptive statistics. We're going to be talking about the classifying, the summarizing, and the presentation of the different types of data that we're going to be looking at today. So one of the first things we're going to look at is how do you read and even interpret information when it's given to you on a table. Now, the table is the collection of related data, and it's just simply arranged in an order so that it's easy to reference or compare. This usually means we're talking about columns and rows of some sort. So when we're reading this table, we want to scan the titles above the columns for the information that we're being sought, and then we want to look down the column into specific rows for whatever fact is required. So here we have a table where we're looking at the 6-month sales report for each of 4 regions, Northwest, Northeast, Southwest, Southeast. And the first question we're asking about that is, what were the Northwest sales of Standard in April? So since we have both columns and rows here, I'm going to look at both of those titles. I'm going to look across the columns, and I'm going to look down, down the first row. I'm looking for Northwest, and I see that Northwest is a row title, and that row encompasses the first row all the way across. I need the sales of Standard in April. So I'm going to find the column that is April, and specifically I'm going to look at just the part of the column that is the Standard, whatever that is. Pillow? I don't know. Standard and Deluxe Pillow? Could be. When I look at that, I'll see that the intersection is 136,700. This would indicate what those sales were, the 136,700. So I've used that particular piece of data. The second question says, what are the Southeast sales of Deluxe in February? So I'm going to look at the Southeast row. I'm going to find February and Deluxe. So I don't just want the entire February column, I just want the Deluxe portion. It's been a long day. And you can see I'm at 91,300 is where they intersect. So that would be the sales of Deluxe in February. Now, there's a third question here, and it is, what is the Southwest total sales in June? So I'm going to look at the Southwest row, and I'm going to find June. And this time we're not distinguishing between Standard or Deluxe. We want the total. So I'm going to look at both of those numbers, the 130,400 and the 74,500, and I'm going to add them together for a total of 204,900. And that's how we would read a table. The second goal of Chapter 21 is reading and constructing line charts. Now, a line chart is a series of data points put on a coordinate grid. They are continuous and connected by straight lines. And what they are used for is the display of a data changing over a period of time. The x-axis or horizontal axis of the chart will be used to measure periods of time such as days, weeks, months, or even years, sometimes decades. The y-axis or the vertical axis is a measure of the amount, the quantity, the magnitude. It's usually an amount in dollars or the numbers of units produced. Sometimes it can be used to measure the percentage of something, a percent increase in sales, for example. And those axes are what we are using to interpret the data. So when we read a line chart, we want to make sure we're paying attention to what the axes are. We want to look at the known variable, could be time, could be the amount of money we have. And we want to draw a perpendicular line from that known value. We want to mark the intersection with the line graph itself. And then we want to use that intersection to go over to the unknown piece and take note of that. Where that line hits the axis is our missing information. Here's what I mean. So here I have a Super Bowl, a chart showing you the Super Bowl 30-second ad rates. Pardon me. For the years 2003, 2004, 2005, 2006, 2007, and 2008. So the question I'm going to ask is, what is the cost of a 30-second ad in 2005? All of these are 30-second ad rates, so that 30-second ad part is not the piece I need, but I do know it's in 2005. So I'm going to go along the x-axis this time because time is often along the x-axis, and I'm going to draw a perpendicular line at 2005. Perpendicular means I'm going to go straight up and down. Now, I can see where this yellow line hits the red line right here. And what I'm going to do from there, right there, what I'm going to do from there is I am going to push over now to the vertical and see that when I do that, it crosses over to 2.3. This tells me that the 30-second ad in 2005 was at a cost of 2.3 million. We have a second example with a multiple line chart. This would be called, a double line chart. We're graphing two different series of informations on the same line. You can see we have a high definition television and an analog television. Analog television are they're like the old style ones where you had to click through the channels. That would be an analog TV. So in what years were the sales of analog televisions less than 15 million? Well, many of you probably have never had anything but an HD TV, which we now call standard definition. And HD and 4K are coming up, but wasn't much more than 5-6 years ago that we didn't have an HD TV. So everything was considered to be high definition. What we're going to do is we need to know when the sales were less than 15 million. So this time they gave me the sales in millions, which is the vertical. So I'm going to follow the vertical line over. And I want to know when analog or when red was less than 15 million. So that would be when the red went down, when the red was under 15 million. So that would be the years 2006, 2007, and 2008. So I need to make sure I've marked that. The second question is, in what years were the sales of the HD TVs more than 20 million? So notice I've got 20 million here on the left-hand side. And instead what I'm going to do is I'm going to draw that line at 20 million. And I need to know when the televisions would have been more. More would go up. So that would be in the years 2007 and 2008. Notice I'm not including 2006 because in 2006 we were just at 20 million. We were not more than 20 million, right? 2006, we were exactly at 20 million, not more. So I'm not including that in this answer. The last question says, what's going on at the intersection of the two lines? Now, the intersection of the two lines is right here at 15 million. And what happens at the intersection is that those two lines cross. At that point, what's happening is that they are both equal. So the sales at that intersection are both 15 million, and the number of sets sold is the same. The second part of this is constructing a line chart. Whether it's a single line chart, a double line chart, or more, these 6 basic things are necessary or needed for a line chart. We've got to evenly space the horizontal axis, that is your x-axis, and keep in mind that that is generally considered to be time. And we're also going to evenly space and label the vertical axis. Now, that is your y-axis. It's usually an amount of some kind, a quantity, a number of days, the percent of a markup, the temperature, but it is some sort of unit, usually other than time. The third thing is that we want to make sure that we've shown each data point. We want to follow the x-axis over, the y-axis up, and then we want to plot the point at that intersection. We're going to connect all of the plotted points. This is a line graph, not a scatter plot. And as a line graph, we will connect each one of the points together. Multiple lines can be shown on the same graph. We've talked about that. You can have a double line graph and a multiple line graph. And you want to make sure that you have clearly labeled the graph. That is, you've given a label to the x-axis, to the y-axis, that's the horizontal axis, and the vertical axis, and that you've given the chart or table a title as well. All right. So here we have a multiple line example. At the bottom of the page, we have data representing the audience statistics of a circus that performed in town. We're going to draw a multiple line chart showing the number of adults and children attending the circus last week. So since the time is the days, we're going to put the days along the horizontal axis, and then the door count, or the number of people who come in, is going to be the vertical axis. Notice on Monday, we have the number of adults as our blue line here. So on Monday, we have 2,300 adults. Notice how that point is plotted on Monday at 2,300. And then for children, we have 3,300. Notice again, that's Monday and 3,300. And then we also have our total, which is the two together at 5,600. You can take any one of these lines in and of themselves. You don't need to put all three on at once, but this is one way that we can then quickly answer some questions. For example, on which day did more children attend the circus than adults? Can you find that? That would be Thursday. That's the only day where we had fewer children than we did adults. What's the lowest total? Which day has the lowest total? Also Thursday. If you look at your total, we can tell that it dips on Thursday. All right. Now, this multiple line graph has several features that are important to note. Each of our lines are a different color. They are not all the same. Secondly, we have labeled both of our axes, the door count and the days. And we also have a title, which is the title of this, the attendance for the circus, June 15th through 22nd. And we've included what's known as a legend. The legend is just a way to distinguish the adult line from the children line from the total line. The next type of graph we want to talk about is the bar chart. Excuse me. Woohoo! A bar chart is a graphical presentation that represents the quantities or the percentages using a horizontal or sometimes a vertical bar. Sorry, horizontal goes this way. Yep, vertical goes this way. These charts are sometimes based on time, sometimes not. There are three different types that we're going to talk about. The first is a standard bar chart. You've likely seen these since grade school. The second type is a comparative bar chart. You may or may not have seen these before. That's the one we're going to concentrate on for this course. And the third type is a component bar chart. Component bar charts have a time and a place, but they tend to be a little bit confusing. So while bar charts may sometimes look like a game of Tetris, they are not. All right, so on the next slide here, what we have is an example of a standard bar chart. This standard bar chart illustrates the decrease or the increase in a single item being quantified. So this is the U.S. college enrollment from 2005, 2006, 2007, and once I got to 2008, then it started being a projection. So this is an older graph, right? It's probably several years old. So if we had to project what the college enrollment would be for next year, we would look at the last few years and see if it's increasing or decreasing. A bar chart is a nice way to determine that. You can see clearly that the enrollment has been increasing over time. But for each year, we're only quantifying one thing, and that's the college enrollment. The second one is a comparative bar chart, and that is actually quantifying two different characteristics. So in this one, we have college tuition from 80 to 81. Now, there are two bars in 80 to 81 because we're actually doing a comparison between two different types, similar, but two different types of quantities. So we're doing college tuition. The red bar is for a public four-year school, and the green bar is for a private four-year school. So while both of these have being colleges and similar, well, both of them are similar because they are colleges. They're different in their types, that is public versus private. And we know that private schools can cost considerably more than public. This graph is just a way of showing us that for each year, we're comparing the characteristics of two different but similar things in order to make the compare and contrast come through. All right. The third one is the component bar chart, and the component bar chart tends to deal with a total, and the bar itself shows the total, and then that bar is broken into two or more components. So in this one, you see that a four-year private school, it gives you the average tuition, and the average tuition of a four-year private school is the $9,000 plus the green of $13,200. What the components are, the bottom component in purple is showing you what the financial aid pays, right there. And the green component is showing you what the student would end up being responsible for. We have done this in this component bar chart with three different types of schools. We've shown you a four-year private school where the financial aid pays $9,000, but the student pays $13,200. A four-year public school where the financial aid pays just over $3,000, but the student is paying $2,700. And a two-year public school where you see financial aid will pay $2,200 and the student is only responsible for $100. So yes, it's really nice to say that in a public school, your financial aid will pay $9,000 each year, but what you're missing is that the student portion is actually still much larger. Versus if you say to your public school, financial aid is paying $2,200, which is considerably less than $9,000, but the student's responsible for only 100. It's nice. So how do you read a bar chart? When you're reading a bar chart, you simply scan the axis for whichever variable is known, and you read the answer on the opposite axis, directly across from the top of the appropriate bar. How do I mean? Here we have a comparative bar chart, and it's successful versus non-successful or unsuccessful instruction. So we're looking across the bottom. We can see the different types or the course style. The course was either individualized instruction, lecture, via internet. The total means we're considering all of them together. And you can see that for the individualized instruction, the blue bar represents the percent that was successful. So 60% of the individualized instruction was successful. The red are those that were unsuccessful or could not manage to pass the course. And you can see that's just over 10%. I would venture to say 12-ish%. And then the third one is a count of the students who didn't succeed and didn't fail. They just can't be counted into either category because they simply stopped attending. All right, so that's with the green bar. I'm reading that off the legend or key. That's important to note. All right, so there are some questions here. The first question is, what percentage of students successfully completed the course when the course was delivered by lecture? So we're looking for lecture and success. So I'm going to go to lecture, and I'm going to read the blue line because the blue represents success, and I'm going to see that that is 45%. The second question says, which delivery methods had a better than 50% success rate? So I'm going to look at the success rate, which was the vertical axis. I'm going to find 50%. And I'm only going to look at the delivery methods whose success bar goes higher than 50%. And that turns out to be individualized and internet. So whether it was individualized instruction or internet instruction, their success rates were better than 50% of the class. I'm not counting that. I'm not counting total in that because the total is just that, a total. So how do we construct a bar chart? Make sure to evenly space, that was fun, evenly space and label the x-axis. Generally, the space between bars should be about half the width of the bars. I sometimes make it more or less than that just because I like my bar charts to look kind of close together, but it's a visual thing, so. Step 2 is to evenly space and label your y-axis. Be sure to include your full range of values needed, lowest at the bottom, highest at the top. Try not to jump too much. It does have to happen sometimes, but we avoid it for the most part. Step 3 says to draw each bar up from your x-axis and stop at your corresponding y value. And step 4 says use a color or pattern to differentiate your categories. Use a key or legend to make sure to identify those categories and label your axes and title your graph. So we're going to use the same circus information. And we're going to use it this time to construct a standard, no, it's not standard actually. We're going to construct a comparative bar chart. I don't know why it has standard there, of circus attendance for each day. Hold on, let me get my pen here. I need my pen. We're not doing standard. We're doing a comparative bar chart. There we go. I don't know if I can write with this. Compare. Oh, this is going to be bad. Bear with me. Comparative. Okay. Comparative bar chart of circus attendance for each day. All right. So here's what it's going to look like. For each day, so those are going to go across the x-axis. Our count is going to go up the y-axis. And I'm going to include for Monday the count for adults, the count for children, and then the total. And so you can see that each day is going to have 3 bars with it because there are 3 categories. So we've got adults, children, and total for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And again, we can tell the same kind of things as we did before. Which day has the fewest number of attendees? Thursday. Which day has the most number of attendees? That would be Sunday. Which day saw the most children? So children is the purplish maroon. So I'm going to go with Sunday on the most children. Which day saw the least children? Looking at this graph, children is the purple. Thursday saw the least children. Which day saw the least adults? The fewest adults. That would be Wednesday. I can tell all of the same kinds of things. But it's also worth noting what's here. That is that your bars are different colors, that your axes are labeled accordingly, the days and the door count, and that we have included a title and a legend. The last type of graph we're going to talk about in this particular PowerPoint is that of pie charts, that is circle graphs. A pie chart is a circle graph that is divided into sections. These are usually expressed in percentage form for us. They're going to represent the components as a part of a whole. The whole is represented by 100%. The wedges or sections must be equal in proportion to your corresponding data. So whatever your data is over your total, this would equal the percent out of 100. This is how we calculate the size of those sectors. So our data out of the total has to equal degrees out of 360. There are 360 degrees in a full circle. So if we have 25 out of 100, that's 1/4. That means that sector or wedge needs to take up 1/4 of the circle. 1/4 of 360 is 90 degrees. The data, the percentages, and the degrees of the circle are all going to be proportional. The good news is that for most of the diagrams you will have to construct for me, the Excel program that we'll be using will do those percentages for you. The bad news is that some of your assignment questions are going to ask you directly how many degrees are in this sector or in this wedge. All right, so here's an example of a pie chart. We're going to answer some of those questions based on this pie chart. You can see we're talking about restaurant market shares from 2006. We have, oh gosh, I can't count, 1, 2, 3, 4, 5, 6, 7, 8 different restaurants accounted for. McDonald's, it looks like, takes up the biggest amount. Domino's takes up the smallest. Notice that all of these are listed in percents. All right, in this particular market, there are 2,415 different restaurants. How many of them are McDonald's? So McDonald's is 39.3% of that 2,415. So what I'm going to do is I'm going to change that percent to a decimal, 0.393, and I'm going to multiply that by the 2,415. Completing that multiplication lets me know that 949 of these restaurants will be McDonald's. How many of these restaurants will be Starbucks? Looking at this particular pie chart, I can see that Starbucks is 14.2% of 2,415. That's 0.142 as a decimal times 2,415, which means I have 343 restaurants that are Starbucks. That number actually turned out to be like a 342.9, and I just rounded it up. Which corporation has the fewest number of restaurants? Well, we already said that Domino's is the smallest. So if you look at the smallest percent, 2.9 is the lowest, and that belongs to Domino's. So Domino's would be the fewest number of restaurants. I don't know how many there are. I didn't figure that out. But if the percent is the lowest, the number of restaurants must also be the lowest. How many degrees in the Yum Brands wedge? Here's the problem I told you would come up. So we can go to Yum Brands, and we can see Yum Brands is 17.5%. That means that that wedge has to take up 17.5% of the circle. There are 360 degrees in a circle, so I need 17.5% of 360, or 0.175 times 360. And when I type that into my calculator, I get a 63 degrees. That means that the size of that wedge must be 63 degrees. All right, last one, hearkening back to what we did last week, find the ratio of Darden to Wendy's. So we're looking at Darden to Wendy's. That means Darden goes first and then Wendy's. Oh, look at the answer showing up there. Crazy little thing. All right, so we're going to do Darden to Wendy's. Darden is 10.2%. Wendy's is 4.5%. So this gives me the order for the numbers, 10.2 to 4.5. Now, these are decimals and they're in a ratio. I cannot have that. So I need to get rid of the decimals. I'm going to multiply both of those numbers by 10. Oops, what am I doing? There we go. I'm going to multiply each by 10 because tenths place is the only place used. So that's going to give me 102 to 45. At which point I recognize that both of these numbers can be divided by 3, and that gives me 34 to 15. This is how I get that particular ratio. All of these types of questions can be asked for circle graphs. All right, how do we construct a pie chart? Well, constructing a pie chart by hand is a bit more involved than what you're going to have to do, but we need to be clear that we need to find the amount of each component as a percent. So we're going to do the amount and divide it by the base, or the amount of any particular category divided by the total. We're going to go ahead and round those to the hundredths. We will then need to figure out what that is as a percentage of the circle. So we're going to multiply that percent by 360 and round to the nearest whole degree. Now you need a circle, a compass, and we need to mark the center. Then we're going to create, we're going to create each wedge and connect it to a line to the center using each radii in succession as we go around. As we label our pie chart, we want to make sure to use color and pattern to distinguish the different wedges. We can't just color them all in black, then you can't tell what's what. We want to make sure to title the chart. We want to provide a legend of which sections or wedges are which, and we want to make sure for our purposes to use percentage on our wedges. No other label, just the percentage. So here we're going to do a pie chart example. We're going to use 15,200 adults, which is our total, attended the circus over the course of the week. We're going to construct a pie chart of the percent attendance of adults each day. So what percent of the 15,200 attended on Monday? What percent attended on Tuesday? What percent on Wednesday? Etc., etc. So in order to do that, I would have taken the 2,300 and divided it by 15,200 to get the 14%, to get 0.14. And then the 2,100 divided by 15,200 to get 13%, and so on and so forth. Each one of these percentages would then be used to figure out how many degrees of the circle I needed to draw it by hand. Now, if we're using Excel, Excel does all that hard work for us, but I might still ask the question, and it's still particularly valid for me to ask the question of how many degrees are in that wedge. So watch for that question, maybe if we're not doing it by hand. All right, looking at this pie chart, a few things to point out. The first is that we did use colors to differentiate, and that it is only the percentages that are on this pie chart, no names of days next to the sector or the wedge. The second is that I have done the other part by using the title and the legend. You can see in the legend that I've put the colors with the days of the week, so I know which color is which, and I've clearly labeled this as adults circus attendance by day, so I can tell what percent and how many days. All right. As you go through this, there is some extra practice in your ebook. We're in chapter 21, the section 1 review exercises. I don't think we want problems 1 through 8. I'm going to X through that again. All right, I could have done that a little better. We want review exercises there. I need to fix these up. All right. So you want to do that. That's just extra practice. It's simply to just sort of strengthen and make sure you're ready to go. Your actual assignment here is graded and is on WebAssign. It's also titled Chapter 21, Section 1, and that's the first assignment due for this new unit. All right. If you have any questions, please don't hesitate to contact me or Tim or to jump on with the Math Center. We are all here to help. Thank you and have a good day.